think about a branch, think about mathematics as a starting point. And we all learn mathematics from preschool, kindergarten, and all of that. After mathematics comes applied mathematics and theoretical mathematics. And theoretical mathematics is where you formulate theories and theorems and so on. I left that behind when I did my first degree. Applied mathematics is application of mathematical principles. Statistics is one form of applied mathematics. And under statistics, you have different applications of statistics. So biostatistics is one, and biostatistics is the application of statistical principles to medical or biological data. So that's where it falls in the hierarchy. In terms of an example, certainly in my experience when I was at the Ministry of Health, we looked at several different diseases. I was in the Health Promotion and Protection Division, so our focus tended to be on cardiovascular outcomes. We also looked at, we were side by side the surveillance unit, so they had ongoing disease surveillance for things like dengue, fever, malaria, any of these reportable conditions. Now, as a statistician or as a record keeper, if you want to call it that, one of the functions is to keep a tab on what's going on. So there's routine data collection, that's part of what we do, routine data collection and routine data assessment. Summarizing data, what are the trends that we are seeing? Are we seeing an increase in trend? Is there a red flag that should be raised at a point because we're seeing the numbers ballooning? So that is routine data collection. Another function is to be part of research studies. So let's say, for instance, as a clinician, you approach me and you say you want to do a study in cancer epidemiology. What is happening at maybe pediatric cases of cancer, maybe at Boston Children's Hospital, and you want to know what are the numbers in terms of trends, or what are the associations, what are some of the exposures that could lead to childhood cancers. Then that could be one use of a statistician. And I'm kind of combining the two, epidemiology and statistics, because in my mind now they're merged. But using mathematical tools, using statistical tools to collate data, to make sense of data when it's collected. Looking at associations between different variables. Why are we seeing a particular trend? Are we seeing higher numbers among males than females? Are we seeing higher numbers in particular age groups? Are we seeing higher numbers in a particular health region? Jamaica is split into 4 health regions, and we can look at data region by region and see if we have greater incidences of disease occurring in a particular region. So these are some of the things that I would encounter from time to time. It's applicable to any disease process in terms of biostatistics. And of course, statistics is wide-ranging. I'm limiting it right now to medical data, but then you can talk about statistics in agricultural data, statistics in economic data, statistics in engineering, and so on. And so it's very far-reaching. You really don't need to limit yourselves to medical data.
That sounds quite exciting.
It is. So I feel sometimes I'm a little doctor, a little medical doctor, but I'm not. I'm far from.
But I think most people have an idea that statistics is boring. But I mean, listening to you, it sounds quite exciting because it's applying it.
It is applying it.
For the development of the country.
Very much so.
Yes.
Very much so.
So, we get back to our very interesting tidbits. So we will come back in shortly and talk about that.
Okay.